For the third example, this is actually an airplane on the amusement park ride that moves along a path defined by the following equations. So we have r is equal to 4 meters, theta is equal to 0.2 t radians, and z is equal to 0.5 cosine theta meters, where t is in seconds. So what we need to determine are the cylindrical components of the velocity and the acceleration of the airplane when the time is equal to 6 seconds. So if you notice, kayong sa right side, mao niyang ilahang mga cylindrical components sa velocity and acceleration. So we have the VR, V theta, VZ, and its corresponding kanang unsayang mga equation. And also for the acceleration, we have its cylindrical coordinates na AR, A theta, and AZ. So let us solve this last example problem for cylindrical components. So just a solution, since ato gipangita is cylindrical coordinates or components sa imohang velocity and acceleration, ang atong buhaton first is mag-time derivatives sa mga tulo ka equations nato. We'll say time derivatives, i-differentiate nato each equation here, the r, the theta, and the z with respect to time. So, first nato buhaton is ang radial. So, that is the r. So, ang equation is 4 meters or equal to 4. So, since 4 lang siya, gisate man ko diri, by the equation, r is equal to 4. Meaning, every time na mag-move ang airplane sa kaning amusement park ride, it will have a constant radius or radial distance of 4 meters. So, kahit unsa pa lang siya na angle, ang iyahang r will be always 4 meters. Meaning, di ba kung equal radius sa kanang every direction or every angle, it means that it forms a circle. Kaya di ba kung sa circle, it will have one radius mismo. Kay, for example, kung mano mong circle, say a perfect circle, so every angle ana from the center, it will have the same radius. Compare na kani atong cardioid na murag heart shape. So, ang radius ana sa every angle will have a different radial line or radius. So, typically, that will be a circle. So, i-determine nato yung first and second derivative. So, ang first derivative, since this is a constant, kay constant naman siya, that would be equal to 0. And the same with the second derivative, that is also equal to 0. So, wala natin problema sa kaning r. Kay 0 na ang iyang first and second derivative. Next is for the transverse. Ang sa transverse or the theta, that is denoted with an equation 0.2t. So this is with respect to time. So pag time derivative ani, diretso na, direct lang atong pag-derivative compare sa itong naay angle na the same kaning sa z na pay theta dot pa sa last. So kani you just only perform directly the pag-derivative aning equation. So kaning t na matay given na time na 6 seconds, di sa nato diri ibutang because this equation is the angle at any time. So later pa nato substitute ang value sa t. So we determine the first derivative or theta dot. So derivative sa 0.2t with respect to time, so 0.2 lang siya. Kay kung data t over dt tapos d 0.2t, so that would be 0.2 tapos d over d.2t over dt rather. So that is 0.2 dt over dt. So mao na direct siya kay tungod mura gihapon with respect to time ra magyapon siya, so makancel out gyapon ning dt. So mao na 0.2 lang ang mobilin dire, direct lang ang imuhang pag-derivative or pag-differentiate. And for the second derivative or the theta double dot or the angular acceleration would be equal to 0. Okay, derivative of a constant 0.2 is equal to 0. So here, at time is equal to 6 seconds, theta is equal to 0.2 times 6. So that would be 1.2. Okay, 0.2 times 6 is 1.2. Okay? So ang unit ani, this is not actually degrees. Okay, basically for angle, kaning sa theta, the basic unit na gigamit ani is radians. Diba? Yun yung pansin kung naka theta dot or theta double dot, radians per second and radians per second squared. So kaning unit nato diri sa theta na 1.2 is naka-radians. So mao na pag substitute nato ani later sa z or sa z coordinate, kailangan naka radians ang inyong calculator. So later nato na siya i-determine. So the last is sa z coordinate. Ang sa z-coordinate nato, the equation was 0.5 cosine theta. So kani, this is an equation of z as a function of theta. So moto na siya theta dot afterwards. Kay with respect to time man nato ang pag-derivative, time derivatives ang tawag ana. So the first derivative, that would be 0.5 sine theta, theta dot. So derivative sa cosine is sine, and derivative sa theta is theta dot. And the same with second derivative, derivative na po nato ni. So like what I've mentioned on the previous examples, these two are different entities or different terms. So we do perform again the product rule. So if we let u as sine theta and v as theta dot, so du is o say derivative sa sine nato. Tao ba kung derivative dili sa koan? Positive sign, no? How about the derivative sa sign? Pila ang derivative sa sign nato? I'm just to make sure kung negative cosine ba or positive cosine. Ang sa derivative nato, unsang derivative sa cosine? What is the derivative of cosine? Negative sign or positive sign? Just to make sure. Negative sign. So, mga don't forget to familiarize the derivatives of the trigonometric function. So, negative sign. So, derivative sa sine is cosine. So, positive cosine. Tapos, theta dot. Then, derivative sa v would be theta double dot. Okay, so, this would be by using product rule. So, gawas lang ni 0.5. So, that is u dv plus v du. So, sine theta times theta dot. Theta double dot rather, or angular acceleration. Plus v is theta dot times negative sine. Sorry. So, negative manino. So, negative cosine. Gawas na tong negative. So, negative 0.5. So, gawas ang negative 0.5. So, u dv plus v du. Du is cosine theta. Theta dot. So, pag simplify ana, hindi natin ibutag sa kilid. That would be negative 0.5 sine theta double dot minus 0.5, distribute mo negative 0.5 cosine theta dot squared. Okay, so once you knew already the value of the first and second derivative, i-substitute mo ang value sa angle and also the angular velocity and the angular acceleration. So just a continuation, at the angle na 1.2 radians, this is when the time is 6 seconds. Ang iyang angle is 1.2 radians. The angular velocity was 0 radians per second, and also the angular acceleration is also, this is 0.2 rather, 0.2 radian per second ang angular velocity. And angular acceleration is 0. So, muna yung substitute sa z dot, and z double dot. Ang sa z is 0.5 cosine 1.2. Ang sa z dot, that was so 0.5 negative sine 1.2 times 0.2. So, mo hang angular velocity, theta dot. And ang second derivative, or c double dot, was negative 0.5 sine theta, theta double dot, minus 0.5 cosine theta, theta dot squared. So, negative 0.5 times 0 minus 0.5 times cosine 1.2 times 0.2 squared. Okay, so if you substitute a angle that is a negative radians, kung naka-radians ang imohang angle, don't forget to change your calculators to radians. So that is shift plus mode. So I believe you knew already about this. You just only click the radians. I think that is 4 para radians na siya. So kung shift mode 4, naka-radians na, because ang default manggod sa calculator is naka-degrees, naka-D. Pero since radians mo itong gigamit diri na angle, kailangan radians atong gamiton diri sa calculator. So, for this one, pila man na ito ang 0.5 cosine 1. What's the value of 0.5 cosine 1.2? .18 or 0.181. Ang unit is meter. Okay? Kaya ka-meters man nato ang unit dito sa problem. And for the first derivatives, z dot, 0.5 times negative sine 1.2 times 0.2. Pila man? What's the value of our first derivative? Kaling z dot. So kaning conjugate ni siya negative. So pila man tong value ana? Negative 0.093. So this is in meters per second. Kay since meter man pag time derivative or pag derivative with respect to time, so ang unit would be in meters per second. So velocity gyapon ni siya. And lastly, for the last one, the second derivative. So this is a 0. So 0.5 times cosine 1.2, 0.2 squared. Pila to ang value sa second derivative. Still that is negative. So times 10 to the power of negative 3. So that is 0.0072. So ang tangira is negative 7.2. 247 times 10 to the power of negative 3. So pag decimal form, that is negative 0.0074 meter per second squared. Okay, since second derivative naman, so the unit would be in meter per second squared. So we do have already the values for your time derivatives of z, the z dot, and z double dot. So for the cylindrical components, of ang iyahang component form or ang iyahang vector form is VR times the unit vector UR plus um, V theta times unit vector U theta. And since this is three-dimensional, napay isa ka term which describes the z coordinate, which is the VZ times the unit vector UZ. So these three are the cylindrical coordinates or components of your velocity. So for the VR, the same lang sa previous examples that is equivalent to R dot. So based sa itong i-compute kanina, that is actually 0. V theta, that is R times theta dot. So that is 4 times 0.2. So that is equal to 0.8. And lastly, the VZ is equal to Z dot. If you, what I shown you kanina sa isa ka slide, atong na ay cylindrical coordinates. So ang VZ nato is Z dot. And that is equal to, base atong gi-compute dire, negative 0.093. So the unit is meter per second, and meter per second. So these are your cylindrical components or coordinates of your velocity. So nanakay values sa cylindrical coordinates sa imohang velocity mismo. So this is your VR, V theta, and VZ. And lastly, for the, just a continuation, for the cylindrical components of the acceleration, the component form or vector form's acceleration in 3 dimension is AR times the unit vector UR plus A theta times the unit vector U theta plus AZ times unit vector UZ. So this is in 3 dimension. Compare itong sa previous example nato, that is in 2 dimension kung wala ning third term. So this is these are the cylindrical coordinates of your acceleration, the cylindrical components. So for the AR, the same lang, that is equal to R double dot minus R theta dot squared. Ang transverse component, that is R theta double dot rather, plus 2 times R dot times theta dot, and the Z coordinate or Z component is Z double dot. So we just only substitute the values. Nakuha naman nato mga time derivatives sa R, theta, and Z. So R double dot, that was 0, minus R was 4, times 0.2 squared. Sa transverse component, that is 4 times 0 plus 2 times 0 times 0.2. So this is basically 0. And lastly, ang sa AZ, that is negative 0.0072. O pila man imo ang AR? What's the value of your AR nato? Or the radial component of the acceleration? Negative 0.16. And the unit is meters per second squared because that is acceleration. Meter per second squared and meter per second squared. So this is your cylindrical components or coordinates of your acceleration. So kung mag-determine mo o magnitude sa velocity and acceleration for the 3-dimension, kung magnitude, Pythagorean theorem lang, since dili ba na kanatong gipangita, pero kung pangitaon na, that is V is equal to the square root of VR squared plus V theta squared plus VZ squared. So, Pythagorean theorem lang. And ang sa magnitude sa acceleration is AR squared plus A theta squared plus AZ squared. Okay? So this is for the 3-dimension. Kung 2-dimension, wala na ning VZ and AZ for the magnitude. So that is for the cylindrical components for velocity and acceleration. So this is for the velocity and this is for the acceleration. Let us see if tama to ang answer. So 0.8. Tama ba to? 0.8? Yep. 0.8. And negative 0.093. Then, ang sa acceleration, negative 0.16, 0, and negative 0.0072. Okay? So, that is how you determine the cylindrical components of the velocity and acceleration. So, take note, kung 2-dimensional, it means polar coordinates. That is R and theta lang. Pero kung 3-dimensional, like what we did here, that is what we call the cylindrical. Cylindrical coordinates, that is R theta plus the third coordinate, the Z. Okay, so that is how you determine or how you solve for cylindrical components. So do you have any questions so far on the examples of what we had? Especially here sa third example. Question so far or clarification? So what you will do is you just take note the equations sa mga components, then mao ninyong gamiton when you encounter problem of a cylindrical component. So question so far,